Welcome to the May 6th Tank Waste Stewardship and Treatment Subcommittee meeting. Before we begin in earnest, I want to run over a couple of administrative items. This meeting is being recorded and will be posted on the Hanford Site YouTube channel. We take attendance for FACA. So if you have not already, we do have a sign sheet in the room. We have one person demonstrating the process. If you're online, we'd appreciate it if you'd enter your name and affiliation into the Teams chat. We have many members online. These owls serve as their eyes, ears, and voice, although you'll see their faces on the other side. So you may want to keep that in mind as you direct your conversations towards the middle. With that, we'll pass it off to our chair.
Yes, I'm Chris Sutton, the chair of the TWIST committee, and I'd like to welcome everybody here. We're going to have two presentations today, discussions really, on areas that we haven't heard from for a while. The first one will be the retrievals process, and the second one will be updates and discussion on the direct feed high-level waste status of that, the plant. We're looking forward to them. But I think before we get started, as usual, we'll go around the table and kind of introduce ourselves and the organizations that we belong to. So Josh, if you could handle that.
Yeah, I'll lead us off. My name is Josh Patna. This is for HAB Facilitation. We'll go this direction on the table.
Yeah, I'm Ricky Bang with DOE's Hanford Field Office as the Deputy System Manager for Tank Waste Operations.
I'm Chris Thomas, also with the Hanford Field Office. I'm the WTP Senior Technical Advisor.
Katie Wong with the DOE Hanford Field Office working on the retrievals program.
I'm David Sauerensvik, H2C Retrieval Operations Manager.
I'm Rob Davis and City of Pasco.
Okay, and along the edges.
Catherine Blakely, I'm a geologist ecology.
Beth Hirschfeld, cleanup section manager at ecology.
Bob Quirk, member of the public. This side.
Megan Tripp, Department of Energy, DDFO to the HAB. Laura Falcon, House Department.
And we got enough folks online to fill every remaining chair in the room. I'm gonna go down the list. You'll be asked for permission to speak before you can due to the recording. So I'll give you a moment to open your microphone and camera when you're ready. Start with Dan. Dan Solitz.
Yes, good afternoon. Dan Stolitz, member of the public.
Amy.
Yes, Amy Green. I'm with Ecology. I'm the project manager for the SSTs.
Dana.
Gosh, it takes me forever to get that microphone open and ready to go. My name is Dana Cowley. I'm with HMIS Communications and I support public involvement. Thank you. Sorry for the delay.
No problem. Desfree.
Hey, good afternoon, Dester Henderson, H2C Communications.
Matt.
Hendrickson?
Yep.
I saw there's a couple. Matt Hendrickson, Oregon Department of Energy.
Kermit. I'll circle back around. Kevin.
Kevin Nadby representing Grant and Franklin counties.
Kristen.
Kristen Kramer with H2C Communications.
Matt Lynch.
Matt Lynch, Nez Perce Tribe, ERWM.
Dan McDonald,
Good afternoon, Dan McDonald with Ecology Tank Waste Treatment Section Project Manager.
Mia,
Hello, Mia Burke with Hanford Challenge.
Steve,
Hi, Steve Needles with Department of Ecology.
Simone,
Simone Anter, Columbia River Keeper.
Susan,
Susan Coleman, Public at Large.
and Michael.
Hey, this is Michael Turner with HMIS TPA Integration.
Circling back around to Kermit,
Hi, Kermit Mankiller, Nez Perce Tribe.
and if anyone has joined us since we started introductions that wants a chance of introducing themselves. Right. So that's the crowd you're presenting to. And with that, I think we're ready to move to our first subject.
Our first discussion this afternoon will be on tank retrievals. Katie Wong with DOE will be the presenter. After her briefing, we'll open it up for comments or discussion from the regulatory agencies, and we'll follow that up by just general discussion, questions and answers from members of the public. So Katie, it's over to you.
Thanks. And I'll take care of most of the briefing, and we have Dave and Katie here to answer questions.
Well, there's been a change again.
That's fine. And okay, you're sharing the slides, great. And we'll kind of go over the retrieval status of West area, and happy to have the dialogue and answer any questions as we go along. We'll go on to the next slide. So again, next slide. Just want to provide an overview before we kind of go with the status, the farm by farm, and that's what we really have in the upcoming slides. Is just kind of more status about each individual farm. But just as a high level overview of tank farms in general, right? There's 177 tanks, both single shell tanks and double shell tanks. They're spread out across the Hanford site in the 200 area with about 19 different tank farms across 200 East and 200 West. In this graphic is kind of that layout and color coding to show the double shell tanks and the single shell tanks. The double shell tanks are colored in the green, and the yellow single shell tank farm, in the yellow would be the single shell tank farms. So you see how the farms are spread out across 200 area. Most of the double shell tank farms are in the 200 East. There are, I think, 6 single shell tank farms in 200 East. And further in this graphic, added in the purple coloring, each tank that had completed, I'll say at least, either retrievals or demonstrated the limits of 2 technologies within those tanks. So they're still going through the process of tank sampling, characterization, and all the regulatory documentation before they're officially complete. So when you look at the retrieval status, you'll see that the C tank farm in the 200 East area, there were 16 tanks in C farm. That's one of the farms that has been retrieved. AX farm, and in the center of 200 East, is the second farm that we retrieved after C farm. And the retrieval activities there, I think, have essentially completed. As far as field operations go, there is some regulatory documentation left with AX Farm retrievals. A Farm is the current tank in the 200 East area that is being retrieved. There's 6 tanks in that farm, and field operations have been occurring on the first 2 to 3 tanks there, and I'll explain a little bit more why I say 2 to 3. What's kind of not shown, what's not really shown here is kind of a sense of the scale, right? So I think as you head toward the Hanford site, you got a good sense of the scale. But really, C Farm down south to AP Farm, those farms are pretty close together in the 200 East area, probably what, a mile apart, north to south. But you have to travel probably another mile or two to get to B complex, which includes the single shell tank farms, B, BX, and BY. And then if you travel west, about 7 miles, you'll reach 200 West area tank farms. Over there, there are 6 additional single shell tank farms and only 1 double shell tank farm in the 200 West area. And so as I previously briefed about the holistic agreement, following retrievals in A Farm, we will pursue retrievals of single shell tanks in S, SX, and U Farm, kind of in the 200 Southwest area of the Hanford site. SY Farm is, as you can kind of see, is adjacent to S Farm, which is then adjacent to SX Farm. U Farm is probably about half a mile just north of SY. And then the T complex with T, TX, TY Farm, that's about, I always think it's about 2 miles north of U Farm. So quite a bit of distance between, B and T complex from S, SX, and U Farm, and kind of the C and it's A, AP, AN, AZ, all those tank farms down in the southwest quadrant. So going back to kind of the overall status, retrieval activities, field activities, I'll say, is generally completed in C Farm with single shell tank retrievals. Same in AX Farm. So that makes it 2 SST farms that bullet is referencing about SST farms being retrieved. 22 tanks would be where we've at least have completed retrievals or have demonstrated or reached the limits of 2 retrieval technologies in those tanks. The 23rd tank was A102, which is the second tank in the A Farm. That demonstrated or reached the limits of 2 retrieval technologies, I think April 30th. So we made this slide before we had, we're just about to finish that retrieval. But that 23rd tank demonstrated or reached the limits of 2 technologies, I want to say April 30th. So currently, the 24th tank that's being retrieved is A106 inside of A Farm, and the tank after that will be A103. That's anticipated to start up in November of this year after A106, which is forecasted to finish up around August of this year. In the lower right corner, a couple of photos of what retrievals looked like. It's kind of a maybe in progress with A101. I don't recall if that bottom photo was a completion photo, but that kind of gives you an interior view of what the tank waste looks like inside of a single shell tank. Some of the various risers, equipment, piping that may exist inside of a single shell tank, and some of what the retrieval team has to work with as they retrieve tank waste from a single shell tank into our double shell tanks. And I'll get into some of the process flow as we kind of go through AX and A farm status. Next slide. Just one slide on C farm status. C farm, this was the first farm that we attempted single shell tank retrievals of. That effort started back in 1998. And again, there were 16 single shell tanks in this farm. I think C farm activities finished around 2018 or so. There was about 2 million gallons of tank waste in C farm that were then transferred into the double shell tank system. It was probably 400,000 curies stored inside the single shell tank. So it's just kind of the radioactivity content within C farm that was retrieved and then transferred into the double shell tanks. Currently, a lot of the farm has been decommissioned, equipment's been removed, but really no activities outside of maintenance really occurs within C farm since it wrapped up in around 2018.
You're gonna put a barrier over it?
So we're working with ecology about future steps with C farm, but the retrieval activities I think are finished, and now a lot of the things like barriers and other actions I think are being discussed with ecology in the closure space. All right, next slide. AX farm. So AX farm retrievals. Some fond memories of AX farm. I think that this was the farm that started up when I first joined the tank farms program. AX farm again had 4 tanks in it. It initiated retrievals in mid 2019. It finished retrievals October of 2025. I think that would be, field operations, field retrievals, reaching the limits of 2 technologies occurred October of 2025. I think initially there was about 500,000 gallons of tank waste stored across those 4 tanks, AX farm, but those retrievals resulted in about 1 million gallons of tank waste being added into the double shell tank system. In this farm, I think the radioactivity was much higher than C farm. Somewhere around 2 million curies were retrieved from AX farm and into the double shell tank system. So from a risk perspective, a lot of good success in removing a lot of those radionuclides from AX farm into the double shell tank system. Effort took 6 years, and I'd say a couple of those years were during the COVID timeframe as well. So work crews did a lot of good work making those adjustments within the tank farms. Accomplished AX 2, 3, and 4 really well. I think AX 101 was the largest tank volume that they had to retrieve out of AX farm, and that finished up just last year. But that was a big lift with AX 101 that they finished. I don't know if I had photos of AX1 on the next slide. I did, yes. You kind of see the interior within AX1. On the left are photos before it was retrieved. And you can see a lot of that tank waste in the left-hand side photo. The white material would be a lot of the what we call salt cake. So tank waste was pretty dry when the crews went into the farm, into that tank to retrieve it, right? So that's kind of dry salt that where water is added into the tank, salt is dissolved. Dissolved salt water is then pumped out into the double shell tanks. All the walls, all those risers, Dave and his team had to rinse all of that off, and I would say it doesn't dissolve readily, right? So it takes a long time, a lot of batches, a lot of water to dissolve a lot of that salt cake. Can't remember if there was sludge in that tank, but some of that material, if there was sludge, would have to be mobilized within a tank towards the retrieval pumps, which would then pump it out into the double shell tanks to retrieve as much of it as possible. AX 101 was certainly a very difficult tank. And I like the kind of the juxtaposition between the before and after photos, where you can really see what it looked like before and after. I think if you look closely at how many of the rings where the tank waste reaches in the left-hand side photo and kind of do that count from the tank dome, you kind of get a good feeling for how full of waste this tank was, about half full of tank waste, and how clean it looks on the right-hand side photo. For AX 101, I'll mention that I think we've done the tank waste characterization. We're preparing the RDR right now, the retrieval data report. So we're preparing the retrieval data report, and we'll submit that to ecology this year. And I think that should be the last RDR that we submit for AX farm tanks. So a lot of good progress on AX farm. Well, I like the before and after photo, and I'm sure I have more, right? I don't know if I have another one after this. Yeah. And that's fine. Yeah, that's fine. A farm is the current tank farm, the third tank farm where retrieval operations are occurring. We started this up after AX 101. First tank in this farm was A 101. There are 6 tanks in this tank farm. You can see a lot more of the infrastructure here in the A farm photo. I think if you kind of compare it to the C farm photo, you can kind of see what's probably been removed from C farm versus what's currently exists in A farm. Dave and his team has taught me quite well that you need power, you need water, and you need ventilation, right? You need electricity to operate a lot of equipment. So a lot of that infrastructure has to be installed and placed inside each of these single shell tanks before they begin retrievals. They have to have ventilation systems to manage a lot of the air, a lot of the hazards when it comes to retrieving tank waste from single shell tanks. And then the water, which supplies a lot of the water that's needed to retrieve salt cakes, supernate from these single shell tanks. And so a lot of this infrastructure had been going through the construction installation phases since, I guess, 2020, at least since 2023 when a photo was taken. It's usually a 2 or 3 year effort from design, procurement, fabrication, receipt, and then construction and installation of all this equipment before operations even begins. So it's really a multi-year effort from design to construction to get to operations with any of these single shell tanks. For A farm, there are 6 tanks within A farm. Retrievals started at July 2024. There's just under 1 million gallons of tank waste spread across the 6 tanks in A farm. A101, I think next slide, yes, A101. So you can kind of see the before photo of A101 on this slide. Slightly different material than AX101, but it's certainly a good visual of where A101 started. The photo for 2026. Not sure, Dave, if you recall if that's a after photo
Yes, it
where
is.
A101 ended up.
It's the after photo with still the liquid covering the solids.
Okay, got it. So A101 has at least reached the limits of two technologies. I believe they're going through sampling, right? Of the remaining any residuals inside of A101. A101 started with 650,000 curies within it. And until we get through the sampling, not sure how much of that has been removed. But it had about 350,000 gallons inside of A101 when it started. And I think it took about 1 million gallons transferred into the double shell tank system before the limits of two retrieval technologies were reached at A101. But that A101 did wrap up this year. No, just last year. Just last year. All right, the next slide. A102. So A102 retrievals. This is one of the tanks within A farm that had a bit less waste in it than some of the other A farm tanks. I think it had about 50,000 gallons initially, which you can kind of see in the left-hand side photo. And Dave, you'll have to tell me too if the right-hand side photo was a mid-April photo or end of April photo for A102.
It would have been in mid-April. We're still doing high pressure water there.
Okay, so it was still in progress at the time that the right-hand side photo was taken. I think I want to say about 200,000 gallons of 200,000 gallons was transferred from A102 into the double shell tank system. And again, this tank reached the limits of two retrieval technologies April 30th. So just last week. And so it'll have to go through all the drying and then eventually the sampling and characterization before it can be officially completed with retrievals. Next slide, I think I have the third tank within a farm that's undergoing retrievals. A106 had actually started retrieval before this month. It had reached about 77% retrieved, and then we went over to A102 and finished out A102 while we were managing some equipment issues and installations of, I think, a second sluicer inside of A106. And so A102 finished up while the equipment installation was occurring within A106. So A106 is the before photos on the left. Started out with about 80,000 gallons stored within A106. It's currently has gone through 20 batches of for retrievals. About 300,000 gallons transferred into the double shell tank system currently. Sits at about 77% complete again. We figured there's about another 2 to 3 months worth of retrieval operations before we would say forecast reaching the limits of two retrieval technologies within A106. After A106 is A103. So A103 currently has some equipment being installed. I don't know if I have a photo of A103 in the slide deck. Yeah, I do. It's wonderful. So A103 will be the fourth tank that would be going through retrievals in A farm. Equipment again is being installed for A103 retrievals. It should start up after A106 is completed, and A103 it's a big tank. There's a lot of material within A103. It's probably about 750,000. No, that's too much. 370,000 gallons of tank waste in it. But I think based on the material that's in there, a lot of salt cake, a lot of solids. So I think it could result in well over 1 million gallons of material being transferred into our double shell tank system with this one tank alone. And could take maybe a year compared to some of the other tanks which have taken less. So A103 will be a big lift to retrieve. But I think again the current plan would be to start this up in the November timeframe. All right, and I think that takes us to kind of the end of the so A104, A105 would be the two remaining tanks that would have to be retrieved out of A farm. They have some tank waste in them. I think they both total about 100,000 gallons of tank waste between the two of them. They also have a lot more equipment, structural challenges with those tanks. We're working with subject matter experts and an expert panel to identify some additional potential technologies for the retrievals of A4 and A5, given some of the challenges that exist with the structure of those tanks. That expert panel has been meeting since October of last year. And I think we expect their final report sometime this year about any additional potential technologies that could be deployed for tanks like A104 and A105. All right, next slide. So with retrieval kind of status and progress, did also want to take some time to kind of talk about the tanks over in the west area as well, because these are the tanks that will be retrieved after retrievals are completed in A farm. There's also been design work occur for the infrastructure needed in the S, SX, and U farms. What you see here are the SX, S, and then SY farm going from left to right. And you can kind of see how there is very little infrastructure compared to A farm, right? You don't see any of the connections between tanks or within the tank farms. It's currently all in a design phase. I think I was just out there last week, and there are power poles being installed last week, right? So mentioned how we need power, water, and ventilation. Last week I saw power poles being installed out on that road that runs along the top of this photo. Design work's going on for the ventilation and for the water systems out there, and a lot of support infrastructure for all the workers that will have to be supporting all the retrievals will have to get built out in S, SX, U, and SY farm. And the SY farm is the double shell tank that will receive the tank waste that's retrieved out of S, SX, and U farm. There's only 3 double shell tanks in SY farm, about 1 to 1.2 million gallons. And that has all the space available for receiving single shell tank waste from single shell tanks in S, SX, and U farm. Next slide. Beyond, I think, the single shell tanks that I discussed, SX, U, and SY farm, there are tank farms, kind of what I call the northern half of the tank farms, and those make up TTX, TY, B, DX, and BY. So these remain really in storage until we have plans to pursue retrievals of those single shell tanks after SX, U farm tanks that have been committed to be retrieved out of west area, and those tanks in east area.
That's barriers.
So you'll see, the barriers over the T. What's at the top? Is that T farm at the top?
Yes.
And then TX at the bottom?
Yes.
Yep. And if you go back a slide, I think you should also see barrier over SX. And then U farm has a barrier as well. I don't think there are any slides after this. All right, so happy to take any questions. There's probably a lot of detail I didn't cover, a lot of detail that Katie and Dave can provide. So if there are questions about single shell tank retrievals, happy to take them.
Okay. Before we move to questions, do you want to check in with ecology? Is there anyone that would like to provide perspective?
Amy, would you like to give perspective?
I'm thinking.
Okay.
I'm thinking. I know DOE and H2C have been doing an excellent job with the retrievals. This last one, they got out as much as they could, and it looked really good. We went out and watched the last of the retrieval process, and it looked really clean. So we're pleased with that. So yeah.
Knowing that we've had Phil join us since we started, is there anyone online from EPA that would like to provide perspective? With that, I think we're ready to move to questions. This is open to everybody. If you're online, which is most likely the case, be sure to raise your hand in Teams. And if you're in the room, you can flag me down like Bob Quirk will lead us off.
A105 is coming up sometime in the near future, right, Dave? And my recollection is that is the tank that about 50 years ago had a steam explosion under the bottom, ruptured the bottom, and a lot of waste leaked out. Are you doing anything different with your retrieval of A105?
Ricky mentioned that we have an expert panel that's going to recommend some technologies for tanks that have structural issues. And so we're going to look at that report once the expert panel gives us those recommendations, and then there will be a process to go through where we develop the technology and then pilot it and go figure out how to execute that.
And when is that report coming out?
This year.
Yeah, expect by the end of the year.
Okay.
Fiscal year,
Calendar year.
Next up, we have Matt Hendrickson.
A quick follow on before I get to my other question. The report, this expert panel. Can anyone in the room or Ricky elaborate a little bit more about that process, how it's been going? And if I remember the holistics correctly with A104 and A105, those are the two tanks you can flex into 200 west. About a year after you receive this report, will that report be made available publicly? and perhaps to this subcommittee?
All right, so I think there are a couple of questions there. How's the expert panel process going? So both Department of Energy and Ecology selected the panel members that made up the retrieval technology expert panel. The department, I think, developed a work plan for the expert panel. And really the work plan followed the holistic agreement language for the milestones related to the retrieval technology work plan expert panel very closely. The panel has been meeting since last year. They have been giving as much documentation, briefings, and information as they can possibly absorb about all the single shell tank retrievals that have occurred, the process, the approach, and then they have also been briefed on really the single shell tanks that remain to be retrieved, the challenges with really our most difficult tanks to retrieve. They've been briefed on things like tanks that are leaking, tanks that are spalling, and they're really charged with figuring out what technologies are available to help us retrieve those tanks with, one, very difficult to retrieve tank waste, i.e. like waste that's been mixed with concrete, tanks that are leaking, tanks that have spalling of the tank dome, right? Because we don't want to increase the risk through our retrievals. We want to be able to retrieve single shell tanks without introducing additional risk to the environment. These are TPA milestones. And so I think as we complete these deliverables, I have to check, but I believe they go into the administrative record. So the panel report should be available. The decision for A104 and A105 is part of the holistic agreement milestones, both the TPA and the consent decree milestones. So the TPA milestones has the TPA has the milestones for the retrieval technology expert panel with the report, with the review of the technologies that are recommended by the expert panel. The department would select 2 potential technologies to further develop for these single shell tanks. And then if we decide that they cannot be developed in time to retrieve A104 and A105, 2 tanks would be swapped for A104 and A105 and added to the 22 tanks that would be retrieved from SX, and U farm by 2040.
Which is part of the holistic agreement.
As part of the holistic agreement and the TPA milestones in the holistic agreement, but the consent decree also has language in it about how that swap occurs.
Was that the follow-on or was that the whole question?
I'll defer for Mia. She gets to go next.
Perfect. All right, Mia, you're up.
Hello. I have a couple of questions. Ricky, you talked about the tanks being retrieved, reaching the limits of 2 technologies. Is that the number of technologies you have available to date to retrieve tanks?
No, there are other technologies available. I think the TPA says, we retrieve, well, maybe the TPA and consent decree say that we retrieve to about 360 cubic feet. 360 cubic feet. If we don't reach that limit, we have to demonstrate that we've reached the limits of 2 retrieval technologies, or deploy a 3rd technology, or demonstrate why a 3rd technology is not, I forget the language, practicable to deploy. So we do that evaluation, we document the rationale, logic, justification. based on the residuals that's left over in a single shell tank, evaluate it against the remaining retrieval technologies that are available, and to determine if it's practicable to then deploy a third technology for retrievals of that single shell tank.
Okay. My other question is one of the last times you were presenting to this committee, you talked about doing dual retrievals, so retrieving 2 tanks at the same time. How did that end up going? Did that work out, or do you have any kind of information to share about that?
I'll provide probably my perspective, which is it went better than I expected. So A102 and A106, I think both occurred, were both in progress at the same time. Retrievals occurred in one tank and then would switch over to the other tank, right? So when I talked about how A106 progressed to about 78%, it paused. It went into, it had a new sluicer get installed. A102 started right behind it. And A102 retrievals finished April 30th, and water was added May 1st.
To the next tank.
Into A106, and then they did a transfer 2 days ago?
Yes.
2 days ago. And so it went from A102 reaching kind of the limits of the 2 retrieval technologies, April 30th. Water was added into A106 almost the next day, and a transfer occurred just 3 days after that. So I didn't expect the timing that Dave's team executed, but his team obviously had that plan and executed it very well. And I think from that perspective, switching from A102 to A106 or A106 to A102 back to A106 happened seamlessly.
That's great. Is that something that you think you'll use going forward for other tank farms?
Dave's shaking his head yes.
Okay. And then just one more question. How are you doing in terms of double shell tank space? Because it sounds like that A103 having so much waste that needs to be retrieved plus water added to make that happen. How are you doing in terms of space to put that in?
I could definitely go down a rabbit hole on this, but let me try to summarize where we are. A106 should have enough tank space in AP101 to finish this August, when we also do a 242A evaporator campaign in July. I think we need about 500,000 gallons of space in AP101. The evaporator campaign will make about 300,000 gallons. Dave's team did a great job with A102, so they didn't use all the space planned that was needed for A102. So there's a little bit of space saved there. And with some other actions that we've taken, like an A102 level rise this year, we should AW102, that'll create additional space in AP101. So we should have enough space to finish A106. Depending on what happens with A106, if Dave's team manages to save some space with A106 retrievals, we could start A103, but we need to be able to feed forward into AP104, which depend on TSCR operations, in order to continue with operations in A103. And then finishing A103 does require continued TSCR operations and WTP operations.
Okay, thank you so much. That's helpful.
And so we're gonna go back to Matt, and then we'll hear Chris.
I shouldn't have let Mia go. She stole my thunder, so I'm going to pivot on this question a little bit. A103 sounds like it's going to be a big tank, a lot of water. I know that 242A is due for a boiler tube replacement, if I'm not mistaken. When you're considering, especially with space limitations, when you start on A103, would you wait for 242A to be good to go for its next campaigns? Or would you do a slight pause in 103, start the retrieval, maybe pause at some point? And if you do choose the pause, how easy is it for you to start back up on the retrieval?
So let's see, on the boiler retube question, that'll occur after the July campaign at the evaporator. I think the retube is planned either winter or spring 26, 27. So that'll occur between this July campaign and then the following campaign, which would be summer of 2027. The reason the following campaign is summer 2027 is because we've concentrated tank waste within AP farm to the point that we just can't concentrate it anymore. So with this next campaign, we'll pretty much have a chance of being able to evaporate anymore from the AP farm tank waste. And so I think to then answer your secondary question, depending on what happens with A106, they could start retrievals. They would pause retrievals. There may be another evaporate campaign next summer that could allow retrievals to restart. And then WTP and TSCR operations will determine whether or not A103 retrievals would be continuous or if there would be another pause.
Makes sense. See you nodding. All right, I think you're up, Chris.
It's like multivariable calculus and DST and yeah, tank waste.
I have several questions also. Limits of technology. I think that's a phrase we haven't really heard much before in this committee. Could one of you give a really concise definition of limits of technology in the context of the retrieval process?
Dave, you want me to do that one?
Please.
Okay, so limits of technology, depending on which technology we use, typically for salt cake tank, there's two technologies that are the primary ones that we operate with, and that's hot water dissolution or just water dissolution, and then high pressure water to break up any conglomerates that are at the bottom of the tank. So the limits of technology, what we do is we continue adding water and we do it in batches. That's why we've talked about batches. So we'll add, say, a certain volume of water to the tank. We'll recirculate that until the dissolution process brings it up to a target specific gravity. And then we transfer that out to the DST. And having a target specific gravity to approach allows us to manage the deep double shell tank space because you're not sending a diluted batch, you're sending the batch that you want with a specific gravity that you've achieved. As you go farther into the tank to retrieve, your specific gravity starts limiting itself so it can't get up to the target's specific gravity anymore. And so once you get to a point where that specific gravity does not get above 1.05, and we recirculate that for 36 hours and it stays below 1.05, then that is a limit of technology batch, and we do 3 of those. With high pressure water, the objective of that, I said, is to break up the conglomerates that are attached to the bottom of the tank or to the walls or to the airlift circulators or the equipment in the tank, because the water hasn't broken it up. If we break it up with high pressure water, that puts that into the pool so that it can be recirculated and be affected by the dissolution process. So those two processes really work in combination with each other to get us to the limits of technology. And so prior to doing our first limits of technology, we start doing high pressure water operations to get all the conglomerates or the crystalline structures that haven't been affected by water into the pool to recirculate. And then when we get to that, the specific gravity, the 1.05 or lower, then we've reached the limit of technology, and we do that 3 times to verify that we're not getting any more salts to dissolve. And so that's really how we define limits of technology.
So when you reach the limits of technology on a given tank, do you declare it retrieved? Or do you say, no, we have to wait for a possible third or what?
We do 3 of those batches in a row. So we don't, once we hit the limits of technology for a first batch, we will put water in there again and recirculate and do that 36 hours. And if it comes up above 1.05, then that would be excluded from one of the limits of technology because you've retrieved some more waste, you've got it in the solution.
And then after 2 technologies, depending on, we look at what remains within the tanks.
Yep.
And then we would determine if a third technology is practicable and then get ecology's approval on it.
Okay, so when you send a report to a completion report or whatever you call it to ecology, there could still be stuff in the bottom of the tank.
There will be some residuals, yes. Unless we've got it all the way clean, but you're probably gonna have at least 360 cubic feet. That's the limit we go to, but we'll go as low as we can get. If we get it down lower than that, we'll keep going until the processes will not get waste out of the tank.
And that's something that you'd have to deal with in a closure process for a
Correct.
tank.
The solids that are left in there would be addressed in the closure process.
Okay. And my last question, when would you anticipate starting retrievals in the SXSY tank farms?
I think we have a TPM milestone for the starting of the first tank. Was that a 2030?
Yeah, April
date? April 2030.
Okay,
So prior to that.
thank you.
All right, thank. We'll have Rob and then Bob, and we're gonna have to do a time check after that.
I know that you presented before to us the different technologies. Could you summarize for the people in the meeting what the principal ones are? And then, for example, the tanks that have been cleaned, which technology, did they all use the same technology or they, give us an idea of how flexible you were for new technology?
Sure. So the main technologies are the salt cake dissolution, which would be adding water to dissolve the salts, and then high pressure also works in conjunction with that. We also use what we call modified sluicing, which is what we use a lot in sea farm, where you take supernatant from the double shell tank farm. At that time, it was AN farm, send it down to the single shell tank that has the waste in it. You recirculate. You have a closed loop system, the supernatant going down to the single shell tank, then the slurry pump from the single shell tank pumping it back up to the DST. And what you're doing there is mobilizing solids because it's probably a slurry tank instead of a salt cake tank. And so that's the third technology that we have. And then we have technologies like caustic sodium hydroxide that we can use if there's a type of component that will be dissolved by sodium hydroxide. We've used oxalic acid part, and then there's some other minor tools, not just almost say minor tools. There's other tools that we've developed like full track crawlers and the Mars arm. So those are really the tools that we've used in the past.
And the tanks that you've retrieved at this point, principally.
The 3 technologies principally are the dissolution with water, high pressure, and the modified sluicing are the main characters.
Okay. Yeah, I know that there's lots of effort to develop those technologies a few years ago.
Yeah.
And we had some mechanical methods. I know Peanut Nail had a contract for dry retrievals and other things. So yeah, it's been a big effort to develop that technology.
Mayor Bob, again.
Yes, looking at the end state, it seems quite different. You know, the picture of AX 101 looks very clean. Yet when I look at your end states for A 101 and A 102, which actually seem to have liquid on the bottom.
So some of those pictures taken are a little deceptive because you're right. We finished retrieval. We pump down the volume as low as we can get it. Usually that pump shuts off with, 3 or 4 inches still left in the tank of liquid. And then before we can sample the solids that are in the tank, we have to let that liquid dry out, the waste to dry out so that we can sample the solids. So you're seeing pictures before the liquid was dried out.
Okay.
That's the difference.
So using ventilation to dry it? Okay.
Yeah.
So we have reached 3 o'clock, which is our scheduled break, if we need it. Is there anything else that needs to be said to close this item out?
No, just thanks for showing up.
Really. Yeah, thank you. I think the status of the tanks and the pictures you showed are just great. So thank you very much, all of you.
Big thanks to really Dave and his team, right? So, I think any feedback or compliments would definitely go to the workforce that's out at the site.
Compliments.
And take that back to the team, Dave.
We will definitely.
So, slightly under 15-minute break.
Yeah, 10 minutes.
Yeah, let's take a break and then we'll
Sure,
start back
yeah.
in 15
Meeting
minutes.
is scheduled at 3:15. Thank you, everyone. Okay, the microphones are on, cameras are on, the room is thinned, and I think we're ready for our next topic.
We're ready for our second briefing this afternoon. And this one will be given by Chris Thomas from DOE. And it will be kind of a briefing and status update on the high-level waste facility that's currently under construction and final design.
Right.
Or something like that.
Yeah, yeah, we'll talk a little bit more about that, right? Pictures often are associated with construction, but we'll talk a little bit about design status because that definitely is a huge piece of it. Many may be aware, right, that the high-level waste facility has gone through a couple of major starts and stops through its lifetime. But in 2023, we kicked off again a major effort to complete the design to 90% per DOE standard 1189 and also weather in the facility. So that weathering into the facility also includes installing significant large equipment that needs to be in the facility before we put the siding and roofing on. So over the top equipment is typically the terminology that we use for that. At the point that significant construction progress was stopped in 2012 last time, we had received approximately 2/3 of our equipment for the facility. And there was a lot of equipment that was in the procurement process. So the pictures here really just give a good feel for where things stood from when we kicked off the weathering in activities to today. And so you can see there at the 58-foot level, right, there was still quite a bit of work to be done in terms of slabs of concrete. You can see today that a majority of the concrete work is done. We're down to a few remaining concrete slabs on that elevation. We also, as of this past week, installed our 54th piece of over-the-top equipment. It was a large bridge crane that went into the facility. And so that allows us to then complete the structural steel you see in the 2026 photo there. It's the kind of the web of structural steel that's going in. It will continue to installation to the right side and to the top left throughout the coming year. So overall, from a design perspective, we anticipate then that we'll complete the final design in late 2027. And then the weathering in for construction will occur in late 2028. The current approach for the HLW facility is to be designed to treat the whole of the Hanford high-level waste tank mission. The initial operation of that facility, in accordance with the holistic negotiation work, as well as the alternative analysis, is alternative analysis 18, which will be fed from the tank farm through the waste transfer vault directly to the high-level waste facility in a direct feed approach. So let's go ahead and shift over to the next slide. And what I'll try to do is hit on some key engineering pieces as we talk through each of these as well. So the first you see here is the installation of a couple of over-the-top vessels. These are the RLD 7 and 8 vessels that were installed in the facility in 2024. These vessels were part of efforts to step through tech issues with the high-level waste facility as well as the pretreatment facility. High-level waste facility had a lot less technical challenges that needed to be overcome. That being said, you have to be able to fund projects to execute construction, and so we had to make some choices on progressing DFLAW and progressing the HLW facility. So there was work that occurred from 2012 to 2023, but it was at a much lower scale than we had done previously. So really setting these vessels was a great milestone in showing the progress that was made during that time, as well as kicking off this latest effort to finish off the facility design. These particular vessels are effluent vessels, and so they deal with the off-gas condensates and other decon liquids that occur during processing. It's important to know from the perspective of the high-level waste facility is very much a remote handled facility. And so as we get into the next pictures here, we'll get into that a little bit more. You can go to the next slide. So this shows an example of, again, major equipment that we put in the last 2 years. This is a shield door. It goes on a crane maintenance area, and so it protects the workers that are working in those areas, maintaining cranes and other equipment from the radiation of those larger process areas within the facility. Extremely thick steel, a lot of conservatism in the design of these components. As we've continued to evaluate the feed for the high-level waste facility, and as we continue to get data from tank farms on it as well, right, as they continue to retrieve, we're continuing to see that there's a lot of conservatism in the design of the facility, which is very positive for the workers who will have to execute the work. These lifts are definitely specialized lifts. You can see the support required to get that, and you can't see the whole of the crane that it took to get that, but that is our largest mobile crane on the project. So it took some effort to get these doors into the facility. But as I indicated, all these shield doors are now set in the facility, which then allows us to complete the concrete placement. This particular door type, there are actually 6 of these particular door types, and it actually moves vertically up and down to allow bridge trains to come into that maintenance area. So, all right, let's go to the next. So this is an example of one of our bridge cranes. So this was the export handling crane that was placed in the facility in 2025. The specific function of this crane is it handles exporting the cast with the HLW canisters, which contain the vitrified waste form, out of the facility and onto the transport vehicle. Also highlights another effort that we have undertook in this phase of the project, and that is an aging and obsolescence review. And so we, given the duration, right, of the high-level waste project and WTP in general, we have some equipment that we've been in custody of for decades, and so well over a decade. And so we utilizing commercial nuclear applications that are out there to look at aging and obsolescence of mechanical, electrical equipment. We were able to evaluate our equipment and determine portions of it that needed to be replaced. And then we are able to allow that then to feed into the plans for when that work will actually occur, when we actually procure the equipment. The key is understanding on these cranes, what work would have to be done in the future, and could all that work be done in the crane maintenance areas within the facility. And we were able to step through that. It was a very positive effort. Shows both the agility of the current nuclear supply chain as well as some of the challenges in procuring equipment, as we looked into some of the details of that with the different vendors. All right, let's go ahead and go to the next slide. All right, so this is looking to the east of the facility and really shows east side progress. So the finished roof line that you see there with the green siding is the annex portion of the facility. For the most part, it contains ventilation equipment. It also contains the high-level waste control room. There is also some secondary off-gas equipment that was within that. So that's been weathered in for some time now and in a finished state. As we move to the north, you can see that in 2025, they were making good progress in that first area where you see rebar being installed closest to the bottom of the picture for covering up with concrete placement, the filter cave access. And so that pour occurred later in 2025, and you can see now based on our picture in March of 2026 that's allowed the structural steel. We're getting ready just to go across that portion of the facility. So so the other piece that I'd like to highlight kind of in conjunction with this slide is what we've tried to do as well as we pick back up this effort is incorporate the lessons learned across the DOE complex. Many of you are aware that the focus for the WTP project has been the DFLAW side of the mission. And we have begun to be able to collect a number of lessons learned out of the startup and early operations of that facility, and then apply those to the high-level waste facility. So the last count, and I anticipate we've crossed the threshold of 1,000, but we had received 999 lessons learned, with the majority of those lessons learned coming from the DFLAW project. But we had also got lessons learned from Savannah Riverside, from different facilities throughout the DOE complex. Also incorporated lessons learned from foreign entities such as Sellafield and Orano. We continue to get periodically employees who have worked in those locations and provide excellent perspective of nuclear operations, particularly in remote handled environments. And then the final piece of that is with the law facility melter heat up that occurred in 2023, WTP really began to develop a 24/7 operations mentality towards operating vitrification facilities on site. And that has been a major shift in the facility forethought. So when we step through the design progress on the high-level waste facility, you're seeing significant input from folks who have experience operating nuclear facilities. A majority of those folks spent time out operating law while we were stepping through various stages of startup operation, testing and operations. Even some of the most recent ones, right, were involved in the hot commissioning that was completed last fall. So overall, a great opportunity to incorporate those lessons learned into the HLW facility and ensure that we draw on those and make the challenges they face less of an issue as we move forward. As many who have worked in nuclear facilities understand, you got to be slow and methodical, and nothing is necessarily ever easy. But our workforce does a phenomenal job of trying to tackle the challenges both on the operational side as well as the engineering and construction side. All right, let's go ahead and go to the next slide there. So this just shows the melter cave progress over the top. So if you look at the picture to the left, you see significant openings in the center of the facility there. To the far right is actually where we lowered in the cranes for the melter cave. Each cave has 2 bridge cranes, one crane with a manipulator arm that's able to handle the many jumpers that are associated with the melter cave. And then you can see in 2026, we've got the majority of the melter cave then sealed up. There are some holdouts that you'll see on the far left next to the structural steel. We've determined it's optimal to place a number of the last remaining vessels. While we could bring them in through the melter export and import paths, it's to our advantage to lift them in via crane. And then you can see on the far right side now we've begun to lay the decking to do concrete placements over the top of those access areas and those maintenance areas, and really then allow the structural steel to complete and then move into siding. The goal is that we'll essentially be complete with major concrete pours. We've already completed the major equipment installations of over the top. And so ultimately then it's into finishing up that structural steel and starting to place siding. We'll begin to receive siding as early as this summer, midsummer, and then it'll start to get installed onto the facility. And that is a huge accomplishment. The reality of it at the Hanford mission is we need remote handled facilities, and progressing this facility provides great leverage and continue to progress the high level waste mission. So. All right. Next slide. All right. So from this side of the house, we get to see a little bit better image on some of the melter cave close up. This gives you just a little bit better angle on it. And then on kind of the far right side of the first picture on the left there, you see the decon and canister handling and storage portion of the facility. And you can see as we go to March of 2026, all the majority of the concrete is now installed there, and allowing us to continue the progress of structural steel installation. So this highlights again another great opportunity as we continue to look at lessons learned, and that is taking a look at the flow sheets associated with these facilities and understanding what are some of our limiting factors, rolling in again additional lessons learned from law relative to effluents, relative to decontamination activities, and how to best allow the high level waste facility to move things forward. And so the team's done an excellent job in completing that work. As we stand to date, we're about 53% of the way to 90% design for facilities in the high level waste facility. And that also includes some balance of facility capabilities that we have to implement with the direct feed high level waste facility. The most significant being the emergency power facility that will provide emergency backup power in the case of a seismic event. So with that, I think that was the last slide, and we can answer any questions that you might have on the status of the high level waste facility.
First, we want to give a chance for regulatory perspectives. I see Dan McDonald preparing to provide one. You're up.
I am prepared. Thank you so much. And thank you so much for the presentation. We appreciate it. A comment first, then several questions. Ecology continues to stand ready during this design completion period of time. We're looking as forward to beginning construction as I'm sure you are. That said, do you still anticipate design completion getting to that 90% by 27 so we can essentially move into construction through that 28 to 35 timeframe?
That's correct, Dan. So, yep, right now we're slated to finish construction in the September timeframe of 2027, 90% design completion. And then weathering in is scheduled for basically September of 28, roughly. So, and I will say the progress by the contractor has been extremely good when it comes to schedule. So I would not be surprised to see that improved upon based on current performance. That being said, they are getting the most challenging systems right, take the longest, and so we are to the heavy lifts. But good progress by the team. So yep, we're in good shape relative to completing design and getting ready to move to that next phase, Dan.
And speaking of challenging, thank you for that opening. As I'm sure you're aware, up to date, the high level waste maturity and the waste transfer vault maturity have been pretty different. Where are we on aligning the waste transfer vault in terms of maturity and ICDs with what we know to be in high level waste at this time?
Yeah, so there has been a couple of things that have occurred, but you are correct in that the waste transfer vault is early. There was a critical decision 0 package that was submitted to headquarters, and that's still in process. So it has not been approved yet, but it is in process. We did go ahead, and the key for the high level waste facility is do we have everything we need to complete the design to treat the full emission? And so we worked an integrated team of HFO, H2C, WRPS previous to that, and Bechtel worked through looking at the waste acceptance criteria associated with the facility and what absolutely had to be defined from a nuclear safety and environmental perspective, and what criteria were focused on essentially adjusting and making most efficient use of the facility, i.e. efficient production of glass. And we were able to separate out the former waste acceptance criteria into those focused on nuclear safety compliance and environmental compliance, which is a much smaller list than ultimately the complete, process control that occurs to ensure we can optimize and efficiently make good glass. So with that, we've been able to then allow the VIT plant team to continue with production while giving the maximum amount of flexibility to the tank farm side of the house, whether it be waste transfer vault design or the mixing and blending design that will have to occur in the tank farms to support a DF-HLW mission.
Okay, that said, it would make sense, at least conceptually, that we'd want waste transfer vault ready at the same time that the high level waste facility itself is ready. Is that your primary goal at this point?
That would definitely be the primary goal.
Okay, and then I have one last question, and then I'll let it go for today. As I remember, there was an initiative right now to update feed factors, and I think it's due in June to determine for sure whether or not we've got the corrosion mechanics and those kinds of things done correctly for HLW. Is that still in process?
Yes, I'm not sure which aspect of it you're referring to, Dan, but I do know that there's efforts underway by the team to complete that on the high level waste side of the house. And there has been, we were able to fund some additional interface with the tank farms contractor to step through some feed optimization. So there is work continuing to go on there. What I will say though is what we're seeing relative to materials, and actually I'm looking right at Rob Davis. The materials that we're dealing with when it comes to the high level waste facility are definitely robust materials. And so we're in definitely a lot better shape than some areas of the Hanford mission because of that. That being said, you've got to understand your parameters on that. And so the team continues to work through the details on that.
Okay, well, I appreciate that. I'm not sure I've ever heard them characterized as robust, but okay, that's good for today. Thank you.
Well, I guess the question would be is what else can you procure in addition to some of those? So RLD 7 and 8 are a great example if you were to look up the specifics on those.
Right.
So yeah.
Thanks.
You're welcome, Dan.
Up for questions and discussion. That is open to everyone in attendance. If you're on Teams, raise your hand like Dan Schultz has, or if you're in the room, flag me down like Chris and Bob have. So we're gonna go Chris, Dan Schultz, then Bob. Bob, Chris, you're up.
Yeah, two questions. For those of us who aren't engineers, could you tell us what the significance is of the 90% design? So I know you have a 30, 60, 90. And what's the significance of the 90?
Okay, yeah, that's a great question. So in DOE standard 1189, its primary focus is ensuring that safety is in your nuclear safety controls, right, are integrated with your design, and that you're lock in step, right? So 90% design from that perspective and in that standard indicates that you are to a point where you have your safety basis defined, and you can then take your equipment design and take it out for procurement. So it's fairly significant progress, right, in that engineering design. Now, what are you still waiting for? You're still waiting for essentially the vendor information that comes back through that procurement process that then you have to feed back into your system. So an example of that would be is maybe you have a piece of a pump or a vessel that you're procuring, right? And in general, the routing of the pipe, right? But you don't know exactly where the discharge of that pump is going to be relative to the design. So the final nozzle locations and that final spool piece, right, are not complete, but the whole of the line is routed, has completed its analysis, and is waiting just for that final vendor input. So that's just an example of what it's ready for, right, and then what information you get post 90 as you take it to design complete.
And my second question is there a difference in the design of the melters that will go into this facility as opposed to the melters in the DFR?
So the size, there's a significant size difference for one. And so that's definitely a case. There's also been some opportunities to
bigger or smaller.
So the HLW melters are smaller. Yep. So and then there's also been some opportunities to take a look at the lid designs and the bubblers associated with these melters and optimize those. And so that work has also been ongoing. And then there's also been opportunity to take a look at the off-gas system associated with those melters and ensure that it's designed optimally to handle the different operating scenarios we see with melters and what we've learned over the last 2.5 years operating the law melters.
And will these melters operate at higher temperatures, lower temperatures, or basically the same?
It's basically the same. It might be slightly different, but it's essentially the same. So
thank you.
Yep.
Next up, we have Dan Solitz online.
Where to start? On the waste acceptance criteria, is that where are you bringing that from? Is that from Old Yucca Mountain, or just for the storage shed? And also on the storage area, is that storage area designed to hold all the waste that will ever be produced from those tanks? And okay. I guess I've got a couple more if you can get to those.
All right, well, let's take those first, and I'm going to take them in simplicity of an order. So the first is there is storage within the facility, roughly 46 slots for canisters. That is not enough storage for the duration, and there is in the plans for the mission an interim Hanford storage facility that will store the rest of those in temporary storage till an ultimate repository is identified. So we do have significant storage, but it's not enough storage for the duration of the mission. And then going back to the waste acceptance criteria. So the waste acceptance criteria that I'm talking about is focused on the nuclear safety basis for the high level waste facility. And so this facility, right, is designed around a certain material at risk. And so you need to ensure that whatever comes into this facility for treatment meets those requirements. Similar to the environmental requirements, there are specific environmental requirements that have to be met for the waste to be processed. And so that is what makes up the whole of the waste acceptance criteria that I was discussing. Now, there is other work that goes on, right, relative to saying, will I get compliant glass? And how do I make that work? And one of the huge benefits in the direct feed HLW work has been the efforts that have been undergone in our enhanced waste glass research to increase waste loadings, to increase our ability to have durable glass forms, and to make those processes also as efficient as possible, because ultimately efficiency and higher waste loadings means less duration and mission overall. So did does that help on the
Thank
first two?
Yes, it did. You also addressed, I believe, it was erosion or corrosion. I wonder if you could also address hydrogen and criticality concerns for the design.
Okay. Yeah, so I would get the criticality terms incorrect, but we have had criticality evaluated significantly for the high level waste facility by both internal experts here at Hanford as well as external experts. The other key consideration when it comes to the high level waste facility is your waste vessels that are handling the waste are agitator mixed vessels, and so that's an important consideration as well. And so, yeah, criticality is not considered to be an issue with this facility, but you do have to meet the criticality safety evaluation report associated with the nuclear safety basis for the high level waste facility. So,
okay, and the hydrogen.
Yeah, and so then the hydrogen as well. So the primary concern with hydrogen really is in your design basis events. So that's your seismic events and your ashfall events. And so there's specific systems put in place to ensure that you purge those head spaces of the process vessels such that hydrogen buildup does not become a concern.
You go back to the waste acceptance criteria for a bit. Would this waste be acceptable at Yucca if Yucca were approved?
Yes, this waste would be acceptable at Yucca. So,
okay, thank you.
Yep.
All right. Next up, we have Bob, and then we'll have Rob. Go ahead, Bob.
Okay, couple of comments. Last week, Matt Irwin said that all the DNFSD technical issues have been resolved. That would include transfer of the solids, the non-Newtonian solids, the flammable gas, and so on. That is correct what Matt said. Every DNFSD issue has been resolved.
That's correct. And so we've gone through with the site reps, right? And they've brought in headquarters staff, and we've stepped through not only where they resolved previously, but what we did is we stepped back through, right, with the team. Hey, here's where we are today, right? As we move forward with DFHLW, are there any additional concerns that we need to be aware of, right? And had discussions with those teams. I think there is still one of those sessions and maybe two of those sessions that we're yet to do, but that does not represent open issues. It represents just communication with the board and the board staff. We did have just here a few weeks ago, Dr. Lee of the board came out and did a tour, and we had the opportunity to brief her as well on key aspects of the engineering design, and she got to also spend a little bit of time out in the field. So,
And all of your lessons learned, it's been evaluated. I assume that would probably include a redesign of the GFR system for HLW.
yeah, so the GFR system has definitely been a struggle in the law facility. That being said, right, they were able to work through that and get things up and going. We're looking at it from a couple of different things. First, we continue to have opportunities to glean lessons learned from law. And so we've tried to approach design of the GFR system appropriately. But we also have capability, right, based on law lessons learned as well, that we know we don't have significant risk to starting up the facility based on what was executed with the DF law startup. So the key with the engineering design is making sure we have, flexibility for the operations team to be able to execute it. If anyone's ever done a B reactor tour and heard about the discussion between what the engineers wanted to build and what the scientists wanted to build, and the engineers adding additional capability, right? These are the type of things that we're talking about, capability to mitigate risk in operation. And so, yeah, great question, Bob, and great, we've got a good path forward to be able to tackle that and get the facility up and going.
One last question. It's been a while since I was out here. Well, more than 12 years now. And prior to that, there was a meeting with a headquarters review of waste treatment plant. I can't remember the recall now. The bottom line is a Bechtel manager, the Bechtel manager at site basically said, hey, let's not worry about all the waste, worst of the waste. Let's get down to the majority and then we'll worry about the waste later on. Is that still the approach, or is DOE believe that all the waste, the Hanford waste tanks can be processed?
Yeah, so there's really two answers to that, right? The plan is that you design a facility that can handle all the waste, but then you ask yourself, do I want to really send all the waste there? And the waste that is of concern is a very small volume. And so really it amounts to what other options are there? And this is stuff that was addressed in some of the alternatives of analysis work. But the bottom line for the HLW facility is design a facility that can handle the waste. And then that gives you flexibility as a complete Hanford team to decide how you'd handle that and handle the most difficult waste at the appropriate time.
The large PU particles.
Correct.
That's all. We should all be able to go to.
And then we have Rob.
Oh, I could ask tons of questions, but the most one I'm curious about is our auto sampler system. How is that shaping up with not having pre-treat?
Yeah, so auto sampling and sampling of waste, is a challenge, and it is a key consideration, right? And so this is another one where we're gleaning lessons learned from the law team, because they are implementing the auto sampler system for their operations. And there are a good number of lessons learned to be gleaned out of that. The differences land primarily in where in the analytical laboratory those samples arrive. And so the team has the opportunity on the design side to say, and step through. We just had a briefing last week by an ops team that had went in and done some specific review of that system in law, right, for recommendations for the HLW design. And ultimately then we're able to negotiate through which of those are actually design issues, which of those are operational procedure issues, and which of those were operator issues that we need to reconsider in design, such that we can, if at all possible, take it out of the operator's hands. So I would say there's still work to do in optimizing that system. And ultimately, the key success in my mind is similar to what we've seen on other Hanford projects, which includes mock-up of that equipment and early startup testing. So,
okay. The rabbit tubes will work.
The rabbit tubes will work.
Hey, thanks a lot.
Checking in with our folks online. Any other questions or thoughts on this? And Nat?
I was wondering, I listened into the cleanup priorities earlier this week. How did, and the way budgets are looking, at least with the president's suggested budget, how did you inform that presentation with HLW?
The one we just gave, or how do we inform moving forward, I think is the better question, right?
Yeah.
Yeah, so I think the reality of it is the only thing we can control is our performance here. And the reality of it is we need to continue to provide robust technical designs that are looked at independently and are viewed the same way, as well as continuing to progress construction of the facility such that we have a facility that can execute a mission. The goal is to make it such that you can't all, but yeah, you need to fund this because we're ahead of the curve. We're ready for it. Let's keep it rolling, right? Let's get the equipment procured. Let's get it installed. Let's get into testing. And so that's really what we have control over, and not what unfortunately the folks back east I am, the good thing is you're all well aware, we have great support with congressional staff and local folks in pushing for budgets. But the budget cycle is the budget cycle, so.
Yeah. And I know that you're ahead of time right now and ahead of budget, you're showing significant improvements there. How much of that would you quantify to those lessons learned from DFLAW and partners overseas or within the nation? And how much of it, and I want to also be careful here that some of these balance of facilities, such as perhaps a second EMF, the emergency power, things that might not be within the HLW footprint, have those all been accounted for within these savings? Or
yes. So that's a great question. So lessons learned are key, right? But I would say lessons learned cause us to reevaluate and make sure we have the right stuff. Is it a cost savings? I'm not sure. I'm technically in the the engineering vein, right? And focus more on what's the design, right, versus what's the cost. But what I will say is that there has been efforts to look at, and we do have within the scope of this HLW effort in a direct feed approach, right, the balance of facilities necessary to operate the plant. And so that emergency power is part of that, right? And what I will say is in part of our efforts to mature that design, we significantly push to say, look, simpler design is more important, is key, right? So, and we were able to make some significant headway with the contractor in making sure we had robust but simple design, and that continued forward. It took some effort, and there's a couple of systems that we'd like to be a little more simple than they are currently. But we have seen significant progress on that front, and that lends itself into that exact point, Matt. Simpler design not only is better for the operators, but it's better to construct and commission.
Okay.
Another chat. Any other questions or thoughts to share? It's open to anybody online.
Chris, you're gonna be in a great place. You're gonna be able to see the place finished. Hey, your career. That is like so powerful.
Yep.
I feel bad I missed it.
Dan Solis keyed up for another one. Go ahead, Dan.
Yeah, can you tell us when we'll be able to see a flow diagram, or is there a flow diagram available?
For the overall, so I think
yes,
it was the alternatives of analysis.
The WTP hollow waste analysis of alternatives. Alternative 18 should have a flow diagram in it.
Would System Plan 10 have one?
So System Plan 10 has, I'll call it, it has words that talk about it. And then another opportunity and recommendation would be if you go to the VitPlant website, they have some high level discussion on operations within the facility. So, but it's fairly straightforward. You transfer the waste in, you mix it in agitated mixed vessels, you add glass formers, you feed it into a melter, and you kick out glass. So.
Couldn't that be also in the ICDs?
So what
the ICDs would not have the flow diagram?
No, they're more interface definition between the contractors. So
okay, because that's where all of our limits are in the appendices.
And yeah, you're working off of the alternative 18 that was put in the addendum at kind of at the end of the AOA.
That's correct.
Okay.
Final words, close one out.
There are no other questions or comments from anybody online or here in the room. We thank you very much for your presentation, and we look forward to another one in a year and a half, when you've done the 90% and the construction's in sight.
Yeah. Oh, it'd be so good.
All right. Thank you very much.
Thank you again.
Thank you, Ricky. Take it easy, everyone.
Oh,
So next up, we have
You got to formally adjourn.
business for the subcommittee. So you don't have to stick around for that, but you're welcome to if you would like.
Laura will be here all day.
Yeah, I'll be here, guys.
Yeah.
Thank you.
I was getting out of here. Oh, darn.
So,
Yeah. Got it.
Here, Ricky.
We're good. Okay, subcommittee business. Oh. What business, what must we conduct, Chris?
Okay, the last part of this afternoon is subcommittee business. Fortunately, or unfortunately, there's not a lot of it. I want to make one comment though, since it was alluded to just a few minutes ago. For those of you maybe who didn't hear DOE's briefing Monday night, public briefing on work priorities and the budget, the major difference between the enacted 2026 budget for the tank waste mission and the FY27 requested budget for the tank waste mission was about $300 million less for the high level waste facility. However, DOE indicated that it was their expectation that this shortfall could be handled by carryover from 2026 and contingency. So if you see those numbers without an explanation, just be aware that at this point in time, DOE believes that it's not a significant issue and can be handled, as I said, by carryover contingency. So I just wanted to say that at the end as a comment, in case you see these numbers without any explanation as to why the big delta for the high level waste facility between 2026 and 2027. Okay, having said that, our next meeting, at least as I understand it, because there's been so many changes, our subcommittee meeting, the next one will be either the 5th or 6th of August.
It's best described as some point in time in the summer.
Or thereabouts, give or take a month. And so the question is, what would we like to hear at that subcommittee? We may not have a lot of options because we have to sort of follow the work plan. Now, the problem with the work plan is some of the things that were supposed to be presented at previous meetings, the previous meetings were canceled. So the things that were in the work plan have never been presented. And then we have things that were supposed to be presented in future meetings, along with those that never have been. So my understanding of this in an email that I sent to Megan earlier this year is that the possibilities that were in the work plan for various meetings that could be presented on August 5th and 6th are as follows. A direct feed low activity waste program briefing, DF law information of DOE order on conduct of operations, a possible closure briefing, and a possible tank integrity briefing. These are all things that are in the work plan but haven't been given. So these are things that we could go ahead and ask for. If people have additional ideas, I'd like to hear them, because if we can't get them this year, we can maybe push them forward in the next year and get those in the work plan for next year. So if you have ideas, let's hear them now perhaps, or email me or Josh. But let's get them down on paper and see what we can do. I think we can be, especially for next year, there's a lot of flexibility because there's no work plan yet. So we have the opportunity to get them in a work plan. For things that are in this year's work plan that are planned or were planned but weren't but couldn't be given because the meetings were canceled, we have the 4 things I mentioned. And I'll go over those again. Direct feed low activity waste program briefing. That is in the work plan for August 5th or 6th, along with DFLAW implementation of conduct of ops. Those could be rolled into one briefing. We could then add a briefing on closure. What does closure mean and what are thoughts? And closure means tank waste closure, not closure of the DFLAW facility at the end of operation or anything like that. We could also then have a tank integrity briefing, which is supposed to have been given at November 5th, 6th committee meeting for the work plan. So those are the 4 things that we could possibly get in for August 5th or 6th. And anything else, I think is open for next year.
What do you think, Rob?
Yeah, I would like to add to that list, and maybe it's a joint meeting between another committee, but we need a discussion on the cross-site transfer and those plans. And the other is an updated flow sheet for HLW.
So a question on the second one, would that be a presentation on its own, or would that just be a supplement to today's?
Well, it could be, because they could end up describing this new vault that they're gonna put in, and now it's gonna interface with the Tisker or that kind of coming in, and then going to the high level waste. They are a number of new systems.
Okay.
If we go down that road, Rob, with those systems, would it be feasible to include what they're thinking now, maybe for the sludge washing? Because they're talking about where they're going to do that, so I figure that's going to be even ahead of their waste transfer vault.
Yeah, right.
Dan Solitz, what do you think?
Question first, are they gonna test through the high level waste before it's put into the direct feed high level waste vitrification plant?
Dan, can you repeat that, please?
I would imagine.
Are they gonna run the high level waste through the Tisker through a cesium removal device before it goes into the direct feed high level waste melters? Did I hear that right?
Well, I don't know. I would imagine that the waste that, well, the Tisker waste that's filtered, okay, goes on the pad. But it's gonna have, I don't think the water's clean enough.
So, Laura's in the room reporting the question, so we can get the official answer, and we don't necessarily have to speculate about it.
Yeah.
But I think that would be a key element of an updated flow chart too.
Yeah.
Yeah, I don't know what the point would be. The Savannah's already made glass, so whatever final repository is going to be characterized will have to accommodate Savannah glass. So, keeping this from getting too radioactively hot, so to speak, doesn't make much sense unless it's going to be above Savannah glass. But I kind of doubt that. So I'm not quite sure what's going on.
Yeah.
Okay, so
Savannah River glass and the DWPF is using a monosodium titanate as glass form or as glass formers. So it's a completely different chemistry.
Okay, but the repository would have to be designed to hold the radiation and the heat. Heat's the biggest issue for the final repository. So I guess the reason I'm bringing this up is there's been a GAO query into would it make sense to not commingle to two not commingle spent nuclear fuel from a commercial plant with defense high-level waste. And if the defense high-level waste is, and it probably is, lower heat, then maybe the characterization would be more forgiving, and it would make it cheaper to build just a defense waste vault rather than trying to commingle them. And might be able to get one sooner and have more national acceptance, because everybody supposedly benefits from having the bomb, as opposed to not everybody benefits from having the electricity from a commercial nuclear power plant.
Other comments or thoughts about additional information we'd like to receive vis-a-vis a briefing?
Me, it does.
It'd be nice to hear an update about NUCON, the technology that that is supposed to destroy tank vapors. I know that I think it was in phase 2 of, I think, a 3-phase plan. So, and we haven't heard an update on that in a while. The other thing was I haven't heard an update on the evaporator, and just a 101 on how it works, and any information that can be shared on that. I know when I first started listening in on the board, there was a need for a second evaporator at some point. That one isn't enough, but I haven't heard anything on that topic since. So if others find that interesting, I'd like to hear about that.
Yeah, on your thoughts about an updated briefing on NUCON, maybe we need an expanded briefing in that regard. Are the vapors expected to be the same as in DFLAW? Are there going to be, could there be significant differences in the vapors that might require a different vapor treatment process than NUCON? Or see where I'm going with that? What comes out of the melters vapors from the high level waste may not be the same as DFLAW.
No, but this is at the tank. This isn't at the facility. This is a tank. It removes the vapors directly from the tank and destroys them. So it's
Yeah.
Before DFO, I agree with that. Existing tanks, they emit vapors.
Yeah.
Either steady state or when you're doing retrieval.
And that's
Whatever.
what NUCON is.
Right, then it would still be treating
Okay.
that.
You think the vapors coming out of the treatment plant will be the same in high level waste as in DFLAW?
The vapors off the melter and
Yeah.
the cleanup system is pretty robust. So it's almost identical.
Okay.
In addition to the, existing request, I've heard, a request for a cross-site transfer line update. Updated flow sheet with including description of new systems, sludge washing needs, pre-treatment needs, a NUCON update or tank vapor status, and evaporator 101, including the need for a new or additional evaporator.
Right.
Anything else to add to the wish list?
No, again, just what would we like to hear? What we like to hear in the August briefing. I don't know how much leeway we have. What's on tap right now for August, based on the work plan, is direct feed to activity, waste program briefing, implementation of conduct of operations, and possibly the closure briefing, the closure of tanks. Those, I think, are things that, unless I get additional feedback, I'll try and reiterate to Megan that we want to go forward with, because we have a lot of time now between whenever our next meeting is going to be and today.
Megan just sent me a note. I know Josh is capturing a lot of the topics. Separate note of any of the briefing requests that you would like, just send an email. That would also be helpful for her as well.
Josh is taking them down.
Yeah, on top, I know, on
Yeah.
top.
In your own words.
Yes, in your
Rather than
own,
Josh's words.
yes, in your own words. Thank you.
Matt, what else do you have?
And I copied you on this in January.
Yeah.
And he sent that to us recently, so yeah.
Go ahead, Matt.
I would like to maybe add a little nuance and clarification for the 242A evaporator discussion. We could also have them talk a little bit about how EMF, what kind of volumes it evaporates versus what it sends to ETF for processing. And if a second EMF is planned for HLW, which I believe it is it going to be of similar volume, size, scope? If we're talking about boiling water off or sucking water off, as it may be in a vacuum, whichever one it is. And at some point, admittedly, it wouldn't be this August, but certainly be next year. I know some milestones are coming up for 200 West that I am, as I'm sure you all know, very interested in, and many folks in Oregon are very interested in as well. But that would be one to push well into 27.
It's a work plan edition. Maybe.
Well, I think that's about it for the day. And I thank everybody, both online and who surfaced here in the room. I thank you for listening in and the comments and the thoughts you have. And stay tuned till our next meeting. And have a good summer in the meantime.
Okay. Thank you, everyone.
Bye all. Thanks, Josh.
Welcome.